This video will be on solving exponential equations. So when we are working with exponential equations, we need to know the opposite. So when we're working with normal equations, so this stuff on the side is just a side note. If I'm trying to solve for x, we've got to get rid of the 1, so we do the opposite and minus 1, because 1 minus 1 cancels each other out. Well, we have a similar idea here. We need to do an opposite. And the opposite of an exponential is kind of weird. It's called a logarithm. And it doesn't act as nicely as the opposite of addition. Addition and subtraction, we just gotta cross it off. This opposite, with logarithms, we're going to put log in front of both sides. And the reason we do that is because now this letter x can move out in front. So we would have x times the log of 7 equals log of 12. So that whole purpose was to take the variable from being up above to down in front. Once we've done that, we still need to get x alone, so now we need to do the opposite of multiply, which is divide. So x would equal log 12 divided by log 7. And now we have to plug this into a calculator. There is no other way. It must be input into a calculator. So we're going to our calculator. I have an online one I'm going to use. We have log of 12 divided by, I need to do a backspace. I think I'm just going to have to start it. Log of 12, and then we want the divide sign to be outside of the parenthesis, divided by log 7. And they want us to go to 4 decimal places, so 1.269, but we have to check the next decimal place to see if we round or not. So the next decimal place is an 8. That means the 9 will round up. When it rounds up, though, it goes to a 10, so that extra 1 has to be added to the 6. So the 6 will also move up to a 7. So our final answer is 1.270. So let's look at a different one. This problem will start the same way, but notice the variable now has this minus 1 attached to it. It's going to end a little bit differently. So we still start by putting log in front of each of them. And the reason we have to do it to both sides is because we're working with an equation. What you do to one side, you must do to the other. Now, everything in the exponent is going to be moved out front. So we have x minus 1. Since there's two things, I'm going to put it in parentheses, times log 4 equals log 5. So we will still divide by log 4. So far we have not done anything different from before. And we still need to put log 5 divided by log 4 into a calculator. Plug that in, we get 1.16096. Again, I wrote this 6 in just to say what's going to happen. Are we going to round up, or do we leave the 9 how it is? It is going to round up to a 0, which means we have to add a 1 to the other number. So we have x minus 1 equals 1.1610. Now we have one last step that will be a little bit different. We want to get x alone, so the opposite of minusing 1 is adding 1. So x equals 2.1610 is our final answer on that problem. On this one, we could solve it the exact same way. Even though there's the 2x in front, we do it similar to the last problem. but they also have some that they want you to solve using graphing. So when we go to plug this into a calculator, we're going to use the left side as one of the functions we plug in, and the right side will be separate. So I just am using an online graphing calculator. I'm going to do 10 raised to the 2x. When we do this, we need to put parentheses around the 2x part. Then for the second function, we're going to use the 22. That is the right side. Now right now on this graph you can't see the 22. I'm going to have to zoom out. The graphing calculator in the GradPoint program, it should be set up already to see. So we want to see where these two functions cross. There should be something called intersection on the calculator. This one, when I was messing around with it, was having trouble. Yeah, it's not going to show me where they cross. But it'll pop up with a point. I did it on my handheld calculator. And when they do these graphing calculator problems, they only want one decimal place instead. So when I plugged that in, I found out that x was 0.67, so the 6 would round to be 0.7. The last kind of problem is a word problem. So let's say a parent increases their child's allowance by 15% each year. If the allowance is now $9, about how many years will it take for it to double? Use 18 equals 9 times 1.15 to the x and round to the nearest year. So if we're rounding to the nearest year, we don't want any decimal places at all. And then really, we can ignore pretty much everything the word problem says as long as we can identify this equation. And once we know the equation, now we're going to solve it the way we have been. Now what's different about this equation though is this 9 in front. We've had numbers up here with the variable, but we've never had this number in front. We cannot use log on both sides. Can't do that opposite until we get rid of the 9. So this is really 9 times, parentheses mean multiply. So we're going to do the opposite and divide. 18 divided by 9 would be 2. We can drop the parentheses now. So now we do our opposite. Now it's just back to one of the equations we've already been solving. We need to put logarithm in front. It makes this x come in front of the log it's attached to, so not in front of the entire equation, just in front of the logarithm it's attached to. And then we need to get x alone, so we're going to divide both sides by log of 1.15. So again, plugging this into a calculator. I think my online graphing calculator had crashed earlier, so I'm just going to plug it into my handheld, which you cannot see. We get 4.95, and it said round to the nearest year. So we're trying to figure out, will this decimal, or will this number go up, or will it stay as a 4? The 9 next to it is bigger than 5, so this will round up. So x will equal to 5.